This is a video presentation of Chapter 1, Section 10, Introduction to Inequalities. So let's go ahead and start off with the definitions here. An inequality is a mathematical sentence that compares quantities and typically uses one of the following symbols. And those symbols in order are less than, greater than, less than or equal to, or less than or equal to. Again, an inequality is a mathematical sentence that compares quantities and typically uses one of the symbols less than, greater than, less than or equal to, or greater than or equal to. An algebraic inequality is an inequality that contains a variable. An algebraic inequality is an inequality that contains a variable. And the solution set is the set of all solutions. The solution set is the set of all solutions. So let's go back and look at these symbols one more time, make sure we have those down. This is less than, this is greater than, this is less than or equal to, this is greater than or equal to. Now one of the things you're going to have to do in this section is you're going to have to graph the inequalities on a number line. And you have to make sure that you know the symbols that match the different inequality signs. When we plot less than and greater than on a number line, those get graphed with an open dot. And that open dot will end up going on the number that's in the inequality. So for instance, if it's something like x is greater than 3, we're going to end up putting an open dot on 3. These last two, less than or equal to, greater than or equal to, those are going to get plotted with a closed dot or a shaded in dot. Something like x is less than or equal to 4. We would then put a closed dot on 4, and then there's also a shading step, which we'll talk about when we actually get to the graphing inequalities in just a moment. As far as solution set, realize because these are inequalities, there's more than one value that can be a possible solution. If we go back to the example I used when we talked about the open dot, x is greater than 3, well, a number like 4 would work because 4 is greater than 3, and 5 would work because 5 is greater than 3, and 6 would work because 6 is greater than 3, and so on and so forth. All those numbers that make the inequality true, in this case all the numbers that are bigger than 3, those are all part of the solution set. And don't limit yourself to just integers. All those decimals in there and fractions, whichever form you want to write them in, those would also be valid solutions. So if I'm talking about x is greater than 3, an answer like 4.9 is perfectly acceptable because 4.9 is indeed bigger than 3. Okay, we'll continue on then. The first question is really one of the easier things they're going to ask you to do here today. They're simply going to ask you to compare two things with greater than or less than. And you can see what they've done here is they've given you a little bit of a simple math problem to work with, and then you're going to plug in the correct symbol. So if we look at 1a, on the left side here it says 23 minus 14. Well, 23 minus 14, of course, is 9, so we're comparing 9 and 6. Well, we know that 9 is bigger than 6, which is why the greater than symbol gets filled in. On the right side, we've got 5 times 12 right here on the example on the right side, and 70 over here. Well, 5 times 12, as you can see, changes into 60. Well, we know that 60 is less than 70, so the symbol gets filled in with less than. And that's all we're doing there. If you're having a hard time, remember that old elementary school concept, the alligator always eats the bigger number. The alligator is eating 9 here in example A. The alligator is eating 70 here in example B. Those are both the bigger numbers. Okay, so let's go on to the real meat and potatoes then of what today's about. Today should really be about solving and graphing inequalities. And as you look at your homework, you can see that quite a few questions on the workbook page are indeed solving and graphing inequalities. So we've got x plus 2.5 is less than or equal to 8. Now what's important here, what you need to know, is that solving inequalities is the exact same thing as solving an equation. So all those rules you've seen when we've done solving equations, I'm going to carry right into this section. So I'm still going to say I'm going to want to keep my variables on the left. And I want to move all my numbers eventually somehow over to the right side. and I'm going to be able to flip the sides if I need to. And opposite side do the opposite, which is key. Opposite side do the opposite again means whenever I have to move something to the opposite side, and remember when I'm talking about sides, I'm meaning left and right side of the sign here, all right, I do the opposite. Notice the only difference from the equations really is instead of an equal sign, this one has an inequality symbol, in this case less than or equal to. If you need to, if you just can't wrap your head around the inequality sign, change the problem to read an equal sign. Solve it all the way through, and then when you're done, put your original inequality sign back in. Okay, so let's take a look here at this one now. Again, using those same rules we used for equations, we're going to say variable on the left. Well, I do have variable x on the left, so that's good. And numbers off to the right. 8 is to the right. Again, when I'm talking about to the right, I mean to the right of now an inequality symbol. Before I would have said an equal sign. So 2.5 is the thing that's going to have to move here. It's got to go to the opposite side of the equal sign because it's just a plain Jane number. That's where they all belong. Right. So at this point then, I'm going to look at this and say there's an addition sign in front of the 2.5. So I want to subtract 2.5 from both sides. And when I do 8 minus 2.5, that gives me 5.5. Notice x carries right down. The inequality symbol comes down. This is the solved form here. This is the solution to the inequality. Now, as you can see, there's also a graphing step. If you remember in the introduction, we talked about the open dots and closed dots. And here's where that's going to come into play. All right, what you want to do is you're going to make yourself a number line. As you can see, they've already pre-drawn that for us. And on that number line, you're going to put a dot on top of the number in your inequality. And in this case, that would be our 5.5. So they're going to put a dot on top of 5.5, which is right here. Now, what type of dot you use depends on which inequality symbol you have. Again, as I showed you in the introduction, when we have greater than or less than, those get plotted with an open dot, while greater than or equal to and less than or equal to get plotted with a closed dot. And we'll talk about why those are different in just a second. But right now, what we need to know is that this is going to be a filled in dot on 5.5 because this is less than or equal to. All right, so remember, what does the inequality say? It says x is less than or equal to 5.5. So 5.5 is part of the solution, but then I've got all those numbers that are the less than part. All right, and that's why I've shaded from the dot off to the left. All right, because all these numbers like 4 and 3 and 2 and 1, those are all numbers that would make that statement true, because all of those numbers are fill in the less than part of 5.5. X is less than 5.5. They fill in that inequality, the less than part. Okay, so then the question is, why do we have the different dots here? Well, we have the different dots because less than, in this particular question, and less than or equal to would plot the exact same way if we just had one dot, because they would have a marker on 5.5 and they would shade off to the left, because if it just said less than 5.5, that would be 4, 3, 2, 1. And the less than or equal to, well, the less than part of that would still make me shade off to the left. Okay, so without that dot, we don't know which one of these symbols it is. So the closed dot helps me realize what this is. Again, these numbers are part of what we defined as the solution set. Those are all the numbers that fill in the inequality and make it true. Now there is one little quick rule I want to make mention of here. For those of you that have had me in class before, you've seen this, so it's not unfamiliar to you. Let's say we had a problem like negative 3x is less than 9. We would solve that by saying that's a multiplication problem. I'm going to do the opposite, which is to divide. You're going to divide by negative 3. And you have x, which is absolutely right, and you have negative 3, which is absolutely right. But the one little hitch here is that when you divide by a negative, the same is true if you multiply by a negative, it reverses the direction of the inequality sign. So I'm actually not going to write less than back in as part of my solution. It's actually going to be greater than. That multiplying or dividing by a negative does that. And as you can see, in this case, that's exactly what I did. I divided by negative 3 down here. Now, what you have to know, though, is that as far as that number on the top goes, where 9 is, that's completely irrelevant. It would not have mattered if that was negative. That one does not flip the inequality sign around. It's the number you're multiplying by or the one you're dividing by. If you're solving these the way I've been showing you, think about the number you're going to add on to that right side. In this case, we added on the -3 we divided by. That's the one that's got to be negative to flip the inequality sign. But again, it's only with multiplication or division. Don't worry about it with addition or subtraction. Multiplication or division only. So we'll conclude here by taking a look at the final example, very similar to the first example. As you can see, the only big difference here is that from that first example, they've actually given us something on both sides of the equal sign to work with, or both sides of the blank rather to work with, something we actually have to compute before we can finish this. So on the left side, we've got 15 plus 4, which is 19. And on the other side, we've got 2 times 9, which is 18. Well, when we compare those, that gets filled in with greater than because 19 is bigger than 18. Again, the alligator is eating the bigger number.